This is the second demonstration of the Model 480i. Fairly large version, extra wide, large table with vacuum cups. Today we're cutting a part we're calling Big Windy. This is an acrylic sheet, vacuum formed or thermoformed acrylic sheet with printed logo on it. The idea here is to use the vacuum cups to hold the workpiece down to the table while we make the cut. The vacuum cups are set up on several different circuits, such that if we lose one vacuum cup, say it's half covered by a sign, we don't lose vacuum on the entire table. Each vacuum cup has a little button in the middle. Unless something is touching the button, we do not pull vacuum at that specific location. And we have them set up on multiple arrays, redundant, much like a car brake system has redundant circuits. So what I will do is I'm going to put Big Windy here on the vacuum table, face down. We will set the blade height, well, actually I already set it, to cut near underneath this flange. This was originally part of a large rectangular sheet, and we've done a rough cut near net shape to get the most of the flange off. So I think I've half covered one suction cup right here. Still isn't going anywhere. So even with half the suction cups not working because this one's leaking air, still has a pretty good grip on it. I'm going to pick it up and move it anyway. I can brute force pick it up, but it's a little easier just to turn off the vacuum circuits. Each of these 4 panels is on a separate valve. I turn the valves off and it comes right up. Yeah, I did it again. There. That should keep that pretty rock solid steady. So the control panel over here includes controls for the blade and the table. For the blade, we have a pneumatic aired cylinder, tension, detention, includes a blade breakage detector. Also has a switch. If you don't have enough air pressure, you can't run the saw blade. Table controls forward, reverse, stop, with independent speed controls for the forward direction and the return direction. So we'll start off by starting make sure it's tensioned, then start the blade motor. On the forward speed, I'll start off with it at 0 just so I don't get any surprises. Press the forward button to engage the forward. Increase the speed slowly. Move it into position. And I'm going to cut this at a pretty conservative pace just because we don't have a whole lot of experience with this specific material and I only have one piece to play with. So that is officially a conservative speed. Let's see how we do. That's about 50% of the maximum advanced speed. A little more resistance there than I like. Back off the speed just a touch. What often happens on these applications, when the blade is cutting there and there, we'll be cutting through 3/16 of an inch of plastic. When we're cutting through the first break in or break out, we're cutting through effectively much more material. Now that we're in the body of the sign here, we're really just cutting a little material. I can increase the speed a bit. That's running at about 60% table speed. so well, I'm gonna increase the speed a little bit more. One thing worth knowing while we're cutting, these cleats, or these suction cups, have cleats in them. So when the workpiece pulls down, it'll pull down hard against these cleats, which gives a positive location, as opposed to the suction cup being really squishy and not giving a good hard location. So you can see the sign isn't wiggling in the least as we cut it. Slow it down here a little bit at the end as we're cutting through that last back wall. There it is. So, remove the scrap piece. Oh, just to make my life easier, I'll turn off the vacuum circuits. And there, it's a workpiece. A little bit of fuzzing, just dust really. And that looks pretty good. So, the power of bandsaws.